Greetings, welcome to 2.5, page 5. We're going to go ahead and get started. Probably 56, 58, the toughest part of it might be just making sense out of what they're asking us to do here. Write the polynomial A as the product of factors. We're going to factor that are irreducible over rationals. Rational numbers can be fractions but cannot be square roots. This is the most important part of that. And we can't have imaginaries in there, no i's. So we're not going to have 4 different factors of this because we can't go to i's. We're not going to go to square roots. So A, I just want to go old school. So A is like our old school factoring here. Like how you would have factored this 2 weeks ago. So this is a polynomial, it's a trinomial. Is it quadratic? It's quadratic on x squared, so it might factor into x squared. If there are factors of negative 27 that add up to 6, positive 9, negative 3. Now right now you ought to all be realizing that, hey, x squared plus 9 now factors, but not into real numbers, and certainly not into rational numbers, which is just a fraction of, just a part of the real numbers. So x squared plus 9 will factor later on when we can go to completely factored form in C. And x squared minus 3 is not the difference of perfect squares. So it doesn't factor without introducing square roots. So that's A. B, now real numbers means we can add square roots to that. It's a bad square root symbol. We can have square roots now, and this might not be obvious to think of, but it will be because you're going to see this a fair amount in the coming weeks. X squared minus 3 could be written as x plus square root of 3 times x minus square root of 3. So if we can introduce irrational numbers, then we can factor x squared minus any number. So f of x could be x squared plus 9 times x plus square root of 3 times x minus square root of 3. And if we FOIL that, we get x squared, good, minus x square root of 3, bad, but plus square root of x3 eliminates it, and plus square root of 3 times minus square root of 3, minus 3. And then C, in completely factored forms, we can introduce I. So f of x equals x plus 3i times x minus 3i times x plus square root of 3 times x minus square root of 3. The sum of perfect squares is factorable in imagination land. And also, if we put this process and this together, we could see that if I had, let's say, x minus, or x squared plus 7, that could factor into x plus square root of 7i times x minus square root of 7i. Okay? All right. 58. That is one big hint for us. They give us a factor of this mess, because I think I'd have trouble factoring that. But if they give us a factor, they give us a good head start. We're going to need some space on this. But here's the story. If I told you that 7 was a factor of 42, that gives us another factor, because 42 divided by 7 is 6. Oh, 6 is a factor of... We can get another factor by dividing. So we're going to divide this. I'm going to go ahead and long divide this, and I'm going to use my horizontal space over here to do this. I'm going to take x squared plus 4 into x to the 4th minus 3x cubed minus x squared minus 12x minus 20. And you'll note I'm not writing too big here. Everything look good? Yep. X squared goes into x to the 4th, x squared, so I put that in the x squared column. Multiply this. Oh, I could have a 0x in here. I'm going to think of that. X squared plus 0x plus 4. So that gives me x to the 4th plus 0x cubes plus 4x squared Remember this, but we are subtracting opposite, 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 and we get 0. We get negative 3x cubed. We get minus 5x squared. Bring down the minus 12x. X squared goes into minus 3x cubed minus 3x times. Minus 3x cubed minus 0x squareds minus 12x, but we are subtracting. And I get minus 5x squared plus 0x minus 20, and I see that this does go in there exactly negative 5 times. So A, I've got, might have wanted to even write that higher, but we'll see what we've got. A, I've got x squared plus 4x times x squared minus 3x minus 5. Can that factor, there's no x here, x squared plus 4, no x. Can this factor, old school method, is sum of perfect squares? Hey, I'm going to be able to deal with that later on, x plus 2i, x minus 2i. Are there factors of negative 5 that add up to negative 3? No. So, I can deal with this later on, but this thing, I'm going to set this equal to 0, and I'm going to solve for x. It's not factorable, so that would give me x equals the opposite of b plus or minus square root b squared 9 minus 4 times 1 times negative 5. That's negative 20, so plus 20, all on 2a, all on 2. That's 3 plus or minus square root of 29 on 2. Those are zeros. If those are zeros, those give us our next factors. B, f of x equals, here we go, can't write too big here, x squared plus 4, x minus 3 plus square root of 29 on 2, and x minus 3 minus square root of 29 on 2. Told you we're going to need some space here. Apologize for not giving you a little bit more space on this. And C, now we got the easy part. We can factor x squared plus 4. The sum of perfect squares is factorable if I can use i's. So f of x equals, let's see, x plus 2i times x minus 2i times x minus 3 plus square root of 29 on 2 times x minus 3 minus square root of 29 on 2. Kind of ugly, but in the same sense, kind of a neat little process there. Just getting comfortable with, hey, we got rational numbers, we got real numbers involved in here, and now we have some complex imaginary numbers in those factorings. Okay, so you're going to want to use some horizontal space, some vertical space over here. I would expect this to be very, very similar. Now, got a cool little trick on these ones for you. Use the given 0 to find all the zeros of the function. Well, there's 3 zeros to this. We know that. And we really have 2 of them. If 3i is a 0, if 0 plus 3i is a 0, 0 minus 3i is a 0. Complex zeros occur in conjugate pairs. Therefore, 2 of my factors are x minus 3i and x minus negative, or x plus 3i. If I were to FOIL those, which I'm going to, I get x squared plus 3xi minus 3xi cancels, minus 3i squared, or minus 9i squared, excuse me, minus 9i squared, but that's x squared plus 9. So x squared plus 9 is a factor of this. So how can we find the remaining factor? Is we could long divide this. However, sneaky ninja long division here. I know there can only be one more term because this is squared, and I need it to the third. Mustn't this just be x? Because I'm going to have to get an x cubed, right? And 9 times this has to be that. Mustn't that be 1? Could that possibly have worked? I mean, what about these? Let's FOIL and check. X cubed, we knew it worked. There's an x squared, it works. There's a 9x, it works, and there's a 9, it works. Pretty slick. You could have done the long division. So we want to use the given 0 to find all the zeros. So my zeros are x equals plus or minus 3i and negative 1. Pretty slick. If you didn't catch that fully, let's see if you can here. If negative 3 plus I is a 0, so is negative 3 minus I, which means I've got factors of x minus this, distribute the minus, plus 3 minus I, and x minus this, distribute the minus, and I get minus minus plus 3, minus minus plus I. Let's super FOIL that. I'm going to get an x squared. I'm going to get plus 3x's and plus 3x's, plus 6x's. I get an xi, but a minus xi. Done with the x's. I get a plus 9. I get plus 3i, minus 3i cancel. And all that's left is I get a minus I squared. But that is minus negative 1 plus 1, so x squared plus 6x plus 9 must be a factor of this. So if I've got x squared plus 6x plus 9, there's only a linear factor left because I just need an x to the first. But this times this has to equal 4x cubed. This must be 4x. Oh, this is plus 10 here. I bet for sure you saw that. This is 9 minus I squared. That's 9 minus negative 1 plus 10. So this is 10. I realized it couldn't be 9 with this being 10. This times this has to be this minus 1. Could that possibly work? What about the 23x squared and the 34x? Let's see. There is 24, or there's 4x cubed. How about x squareds? Minus an x squared plus 24x squared. Got it. How about the plain old x's? Minus 6x plus 40x, 34x, 10, negative 1, negative 10. Actually works. Now you could long divide this, but I like sneaky ninja approach here. So let's go ahead. Our zeros are x equals negative 3 plus or minus I, and set this equal to 0, add 1, divide 4, 1/4 is a 0. Okay, so not a real long page, although I guess I can't really say that because it got a lot of steps up here. Should be done with that in probably 12 minutes or so, hopefully. If not, let me know what I can help you with.